before with the implicit differentiation. So let's take a look. If I were just doing the derivative, and we know if we want to get to a second derivative, we have to do the first, right? We did that yesterday, so let's start with that part. What would be my first derivative?
4x cubed plus 4y cubed y dx.
So you do the derivative of x to the fourth is 4x cubed. Derivative of y to the fourth is 4y cubed, but every time we do the derivative of a y, we put dy dx with it. And the derivative of 16 is 0. So if I told you to solve for dy dx,
Subtract the 4x cubed and divide by the 4y.
so my first derivative turns out to be negative x to the third over y to the third.
I
All right.
think you're gonna have to do the derivative of the y to x.
What? Okay. So I need the second derivative. Now you can call this, I'm using dy dx's because I don't trust my y primes to look like y primes and not turn into a y in the middle of a problem. If you are really good at keeping your stuff straight, you're welcome to use y prime. If you are doing y prime, then you can call the next one y double prime. If you're using the dy dx notation, it's okay. They put the second derivative, the notation is d squared y over dx squared. Don't shoot the messenger, I didn't write the notation, that's just how it's written. Okay, so you can call it y double prime if you want. I'm going to stick with dy dx's because my tick marks get lost as I go through a problem. So then I have to do the derivative of this. What would I have to do?
The quotient rule, wait a minute.
So low d high, derivative of the top,
Negative 3x.
minus high d low, derivative of y cubed,
2y squared dx.
3
I mean, yeah.
dy dx over low squared. Can I go ahead and just write y to the 6th? All right. So I'm cleaning this up. I have negative 3 x squared y cubed plus 3 x cubed y squared dy dx over y to the 6th.
Can we take out y squared? Or does that, or not?
Yes, we can reduce it, but I want to do something else first.
Oh, we ran out of space.
What? Yes, very good.
Oh.
We don't want to leave a dy dx here. But what's dy dx equal to?
Negative x cubed y cubed.
Okay. So I'm going to sub that in.
Did we do this yesterday?
Nope, we
Or
didn't do it.
We did the plug in yesterday. We did something.
We plugged in numbers for x and y. But we didn't do the second derivatives yesterday. Okay.
Is that how we're leaving it? No, we're gonna just reduce. I don't have enough space, so I have to.
Sorry.
I have to do all the last step at once.
Probably like 2. We could probably do it in one more line. Depending on
I'm
if I
just gonna-
confused anybody.
So-
Alright. Is everyone with me to this one? Is it okay to leave a fraction in a fraction?
Absolutely
No.
not.
Let's start first though. If I just look at this term, I could reduce the y squared and 2 of those y's, right? So now it's just a y on the bottom. for this problem, I'm going to write out this step to show where I'm at. You don't have to if you understand. But when I'm multiplying those, 3x cubed times negative x cubed, that would be negative 3x to the 6th. And I still have that y to the on the bottom. So this is where I'm at so far. Again, this step is kind of optional. You don't have to write this part out. The problem is I don't want to leave this y on the bottom. So how could I easily fix it?
Just multiply everything by y.
Do it.
Everything on top and bottom gets multiplied with a y. So we get negative 3 x squared y to the 4th minus 3x to the 6th over y to the 6th.
Oh, this is another one.
Alright. We should probably throw in another one of those, shouldn't we? I don't think I gave you another one on there. So I'm gonna add this on the end, or you can get some notebook paper if you want to take a
Big
little
spot
space.
for it.
We'll do another one for sure. We can try more if we need.
Oh, where did I get a post-it from, dog? What?
Do I need to look at it?
No, I just like added a positive somewhere.
Huh.
Change the negative.
Pop off.
Oh yeah, I like the positive numbers apparently. Just a positive guy.
Okay, so I want to find y double prime.
Did you just make this up in your head, or is this one you know is in the book?
Oh yeah,
Oh, I made that up.
this makes
Sure.
Okay. I mean, will anything work when we're not solving with real numbers?
I mean that we're starting to get into the danger zone of making up problems that can turn nasty in a hurry. But this one should work.
We are. What if it doesn't work?
We'll figure it out. Okay,
show this if you really don't.
so a cube root is the same thing as what?
1/3.
Okay, so that's like an x to the 1/3 plus a y to the 1/3 equals 12. So, our first derivative of x to the 1/3 be 1/3 x to the negative 2/3 plus derivative of y to the 1/3 be 1/3 y to the negative 2/3 dy dx equals derivative of 12 is 0. We're solving for dy dx. I think you had one yesterday that we didn't do the second derivative, but the first derivative turned out similar to this.
Yeah.
When I divide, my 1/3 and negative 1/3, divide and just leave a negative 1. Strongly recommend on these to clean up your answer as much as possible. Any simplifying you do ahead of time is really going to help here. So what could I do?
Divide or take so it's the top.
Yeah, they both have a negative exponent that changes floor, so the y will come up
Shoot,
and the x will go down.
that would make more sense.
And that way we don't have negative exponents.
Yeah.
For now. Is everybody with me to here? So now if I want the second derivative. So you can call it y double prime if you're using that notation. If you're using this one, d squared y over dx squared.
Where does our name? Sorry. Let me let me do quotient rule. Does our negative just go with the first term?
So low. D high. What's the derivative of the top?
2/3 y negative 1/3.
Negative 2/3 y negative 1/3. And it would have to get what with it?
I have a question.
Mm-hmm.
So, if it's dy dx, if we did y prime, it would just be y just to the first. Or like, sorry,
It'd be y prime.
prime, it wouldn't be to this, like, to,
No. It's just the first derivative, so just y prime. Minus I d low, derivative of the bottom. 2/3 x to negative 1/3. Over low squared, so that becomes x to the
so that.
okay. This is pretty.
Oh, yeah, it is.
I have negative 2/3 x to the 2/3 y to the negative 1/3 times what's dy dx? Minus negatives plus.
We cancel all of our x on the fraction? Okay.
Is everybody looking to that was what we had dy dx equal to. So I just replaced my dy dx. Other questions?
Oh, that turned out pretty nice.
So now
Oh,
x to the 2/3 cancels from both of those. So I have a negative 2/3. Oh, actually it's positive now, isn't it? Two negatives make it positive. Y to the negative 1/3 times y to the 2/3. You add exponents, so that's 1/3. Plus 2/3 x to the negative 1/3 y to the 2/3. Or x to the 4/3. Okay, there are varying degrees of how much we can simplify this, but at the very least, what should we do?
get rid of the fraction.
So we would take everything times,
X to the, not, how do we get 9/4?
that's a 4/3. It's just, I wrote my 4 small and it closed it.
So we have y negative 1/3 and y 2/3. So
Oh,
a negative.
I missed the negative. That's why, okay. I thought it was a positive 1/3, so it would be full.
All right. There are other things you could do if you were trying to move the negative exponent out of the top. We can, but we wouldn't have to. We could multiply by x to the positive 1/3. And that would simplify it a little bit more, but it doesn't really change a whole lot. So, lots of different equivalent ways you could have your answer written. But at the very least, I do not want you to give me a fraction and a fraction. You can clean that up. All right, so these second derivatives get long in a hurry. And we could keep on going from that point. I could ask for the third derivative, the fourth derivative. We could just keep going as long as we wanted.
Guessing a negative could kill it though.
Yes. Yes.
That's happened to
You
me
get to write
twice
first
now.
derivative, you're just.
Oh,
Well, you would be toast if you didn't have a teacher that gave you partial credit. You know?
yeah,
Oh, it's.
What?
that would be crazy.
All right.
I wish I was toast.
I say that all the time.
Being toast would be fun.
would be a lot easier to grade, just right or wrong.
Just like be bread and
Let me
then
just
Do you ever
mark it
consider
nice.
it?
get warm and turn
No.
into a toast.
No,
I've done
never?
it.
No,
I've done it.
just doesn't seem
what,
fair.
At what point is
Okay.
bread toast?
Let's do, can I just throw up another problem?
How far does it have to be toasted?
Wait, another
before
one
you
of
make a
these?
switch to
No.
toast?
I mean, do we want another second derivative problem?
I'm confident.
They're lengthy. Concept wise, I think we've got it, but I think I want to practice. I don't want to make this one up because it will be bad. Okay.
That's reassuring.
How toast do you have to be?
Before we go on, we can plug in the first derivative into the second one the moment we take the derivative of any y, right? Okay.
Is this one you're just making up?
I'm not taking it out of the book, but yes, it's not one I put on here. It's a review from yesterday, but I figured we should do one.
Like the center of my head is right here.
How long does it have to be toasted for it to be considered toast?
What?
Still says brown.
Okay.
All right.
Okay.
So-
There's two Y's. Oh no, there's two.
Can we try this? Or
Oh,
do you
yeah.
wanna
Yeah,
change it?
try it. Sure.
Oh yeah, I'm switching to the back side.
Here's the last problem of the day.
Yes.
So
Take it off.
we do our derivative. You do have to treat this as a 2x times a y. So derivative of x squared is 2x plus product rule. Derivative of the first times the second plus the first derivative of y is dy dx minus derivative of y squared is 2y dy dx plus derivative of x is 1 equals 0. It looked like most of you went ahead and solved for dy dx. So you have to subtract over the 2x, the 2y, and the 1. Leaves these terms over here. Can I go ahead and just really skip a lot of steps?
Yeah.
You see, most of us, like someone in here, was not solving for the right thing.
Well, you could technically solve an x or plug in x and y because I never said you had to write this equation.
Also,
If you move things to the other side, all of your signs will be flipped, but we should have something equivalent to this. Okay, that's our derivative. We know the derivative gives us the slope of our line. So to find our slope, we plug in the x and y. So we get -2 minus 4 minus 1, so -7. Over 2 minus 4 is -2, so we get 7/2.
Yeah.
So y equals mx plus b, so 2 7/2 times x plus b.
it's crazy we're still using this stuff from like
8th grade.
algebra 1.
Yeah, I'm looking at this, I'm like, dang, that's how they taught us this.
It's like I remember being awful at this ages ago.
I wonder
And
why
now-
we learned it.
We've got it. Alright, so we have our equation. Yesterday I gave you the first chunk of problems. I should have taken off, there was one of those that you can't. 17.
Oh, thank goodness.
Yeah, you cannot do 17 yet until
yes.
tomorrow. So, skip 17 until tomorrow, but now you can also do 35 and 36.
Can